Imagine we have a hotel with a no pets allowed sign at the door. Now, if someone shows up with a dog, they can't enter unless they have a certificate that says pets are allowed. So that certificate is like a toleration in the Kubernetes. In the Kubernetes, we can taint a node just like putting a no pet sign, and only pods with matching tolerations, that is certificates, will be allowed to run there. Hello everyone, welcome back to the channel. I am Nikhil Kumar. In the last video, we have explored how labels and the selectors helps us assign and organize workloads. But if you want the opposite, to keep certain pod off specific nodes, unless they explicitly tolerate them, that's where taints and toleration comes in. So basically how taints work. You can taint a node using a kubectl command. So we have a command called kubectl taint node and the node name with the key value pair and the effect. We have a different type of taints effect. NoSchedule. In this, the pod won't schedule unless it tolerates it. Then we have a PreferNoSchedule. In this, it tries to avoid scheduling unless anything needed. And at last, we have a NoExecute. It evicts already running pod without any toleration. So this is our Kubernetes cluster, and we have two nodes here. One is our RKE2 server and another is RKE2-agent. But if we want to taint this particular node, that is RKE2 server, that none of the pod will be allowed to run on this node, so we can taint it. So for that, we can run the kubectl command. For that, we can use kubectl taint nodes and the node name, that is RK2-server, and the key value pair I am giving dev here with the effect, that is NoSchedule. Now the node got tainted. Let's verify this. Kubectl describe node and the node name. And if we go up, we can see we have a taint applied to this node. We have used the NoSchedule. That means only pods with a matching toleration can be scheduled in this. Now let's talk about taints and toleration in Kubernetes using the simple diagram. On the left hand side, we have a Kubernetes node that has a taint with a key value pair and the effect, just like we did in our Kubernetes cluster with the same label and the effect. So this taint tells Kubernetes not to schedule any pod on this node unless those pods specifically tolerate it. On the right hand side, we can see we have two pods. The green pod has matching toleration, that is key value and the effect. So Kubernetes will allow it to schedule on the node. But on the other hand, we have a red pod that does not have any toleration for the taint. Therefore, Kubernetes blocks it from being scheduled on this node, which is indicated by the red no entry sign. Taints and toleration are very useful for isolating workloads, scheduling critical or special purpose pod like GPU based or system level jobs. Think of it like this, like taints repel everything, but toleration act as exceptions that allows some pod through. This mechanism gives us fine-grained control over where workload can run in the cluster. Now that we have understood what is taints and toleration, let's see it in the action. Just now we have tainted one of our node. So in that case, if we try to create any pod, it will not be allowed on the RK2-server node. So let me create one manifest file. So for that, let me copy this pod file and pod-tolerate.yml. So let me give the name. This will be with no toleration. Let me create this one. So it will not be running on the RK2-server. So let me apply this pod-tolerate. The pod got created. Let me verify this. kubectl get pod. The pod is in the pending state as of now. Let me run this command again. It's still in the pending. Let's verify this. So let's describe the pod, what is happening behind the scene. As we can see that both the nodes are not available. One node has untolerated taint. So let me see what is happening on the node side. We can see that RK2 agent 1 is not ready. but the RK2 server is ready, but it's not able to schedule it over there because we have a taint over there. As we can see in this particular description that the agent is already down, it's not in the ready state, but the RK2 server is ready, but we have a taint already applied to it. That's why it's having a untolerated taint for that. Let me run the same command, kubectl get pod -o wide, and we can see it's in the pending. But if we want to tolerate this particular taint, we can modify our file, that is pod -tolerate, and in this we can add the section under the spec, that is tolerations, and we can specify the key, that is env operator. We have used equal over there, and value, that is dev, which we have used, and we also need to select the effect, that is NoSchedule. Let me apply this, kubectl apply -f pod -tolerate. Now let's see if we are able to see the pod. Now the pod is in the running state, and if we describe it with the void, so we can see it's running on the RK2 server node only, because that RK2 agent 1 is not in the running state. So basically without this toleration, it won't schedule any pod on that particular node. Just like we saw, we updated our manifest file to tolerate this particular taint using this particular section, that is key value pair and the effect. Then only it allows us to run the pod on that particular node. But if we want to remove the taint from the node, so we have a command for that, that is kubectl taint node and node name, that is RK2 server, and the key with the hyphen. Basically the trailing hyphen tells Kubernetes to remove the taint with that key from that node. So let's apply this. So the taint got removed, and if you want to verify this, kubectl describe node RK2 server, and if we grep for taints here, there is nothing. Let me describe it completely, and we can see it shows none over there. So where taints and toleration works, we can use them for isolating critical workloads like control plane or the monitoring, use it for the dedicated AI/ML jobs, keeping regular workloads off infra nodes, and at last evicting non-critical pods under the pressure. That's it for today. You now understand how to use taints and toleration to enforce pod placement policies and keep nodes safe. If you found this helpful, don't forget to like, share, and subscribe for more content like this. Thanks for watching. We'll see you in the next one.